Hello again. This is Math 2270 coming to you from the College DuPage, and the title of this lecture is Midterm Notes. As always, please be attentive while watching this video. By way of introduction, as you know, the final exam in this class is comprehensive and high stakes, so this video is prepared to help you prepare from the first part of the class. More specific guidance will be provided about the final exam content as the final exam interval draws near. I have also opened up Blackboard so you can see deductions by problems from the midterm, and passwords were revoked and the time frame extended, so that should be good for you to go. The exam problems either came from or were very similar to problems from textbook sources. These are where I drew the problems from. I think the source in many instances was the classic 5th edition, but it's very similar to your current textbook. Problem number 1 was a modeling problem, and you had to look at the inputs and outputs of a tank where things were being mixed. The answer that you should have got, this is a linear first order differential equation to solve once you set up the model. A of t should have been 50 plus t minus 100,000 over 50 plus t whole squared. And there was a part B, and the tank was losing 4 pounds per minute, and so it will take, actually not pounds, 4 gallons per minute, so it would take 25 minutes for it to get empty. Problem number 2 was a Bernoulli equation. This is the key right here, and the solution you should have gotten was 1 over y cubed is equal to 1 plus c times the whole of 1 plus x squared. Problem number 3, this is a Clairaut's equation, and you should have gotten 2 solutions. One is y is equal to cx plus 4c plus c squared, and the parameterized solution was 2 over t cubed 3 over t squared, or you could have rewritten that as 4y cubed is equal to 27x squared. Number 4 was an exact equation, and the solution you should have gotten, it was an initial value problem. The solution you should have gotten was xy squared minus y cosine x minus arctan of y. And this is the value of the constant, and I put the constant on this side rather than on the other side. This was a straightforward homogeneous differential equation, second order differential equation with constant coefficients. It was an initial value problem. Your answer should have been y is equal to e to the 4x times 4 cosine x minus 17 sine x. This problem was a homogeneous problem, so you do the substitution y is equal to vx, and it turns it into a separable equation. But then you have to reverse your substitution at the end. The solution I was looking for was x ln absolute x minus y minus x e to the y over x equals cx. Number 7 was a first order differential equation with an initial value condition, and so your solution that you should have gotten was y is equal to sine of x times cosine of x. That could have been written differently, I suppose, using a trig identity, and then this is minus the cosine of x. Question number 8 was separable. Your answer, and it was an initial value problem. You should have gotten x is equal to the tangent of 4y minus 3 pi over 4. Question number 9, this was d squared minus 4 operating on y, and you could have done it as an annihilator, but you would have had to use a trig identity here of, and that's either the double angle or the half angle formula that you would use here, so it would be something that you could annihilate. That's the approach I would have recommended. Number 10, the directions you were to use a reduction of order to find the solution, and the other solution is a constant. You could have gotten any constant, but I chose 1. Problem 11, this was a Cauchy-Euler problem, and it had initial conditions, and so you should have gotten y is equal to 16x squared minus 2x to the 4th. Problem number 12 also was a Cauchy-Euler equation, but over here you would have had to use variation of parameters because there's no other way to do this. You should have gotten y of x is equal to c1 over x to the 10 plus c2x squared minus 1 over 7x cubed. In closing, now more than ever, time is precious. Each day must count. Do the math. It will make you strong. And now more than ever, take care of yourself and of each other. Strive to make a difference each and every day. God bless you all, and look forward to seeing you in class soon. Until then, take care.